liquid fluid, right? So that what's the typical way we use this kind of like a refrigerant, right? So that the important thing is what is necessary. What kind of important thing we want this kind of a liquid to use in air conditioning system? We need to have a good thermodynamic property, what we mentioned in previous heat transfer lecture. Thermodynamic, so that we enable what? Much more efficient heat flow rate. Well, remember Q, heat flow rate equals what? Area and also H delta T. So that so in this case, if you have a much better thermodynamic property of working fluid, then you may probably carry a lot more heat flow rate based on previous lecture. So that that is something I hope you still remember what we mentioned in previous lecture about heat transfer. So here, maybe just put down more specific thing, right? Remember we have Q equals heat flow rate, right? For this kind of thing, we need to have a Q and equals what? Area, H, and delta T. Temperature difference, delta T. Why? So H, all this relate to thermal property and also heat convection. So that in this case, if you choose those kind of thermal property, thermodynamic property of those things which has higher this kind of heat capacity or thing, right? Increase heat flow rate, right? So that is important thing, right? And then so that that's in relate to the thing. Of course, those kind of working liquid now or refrigerant who have what? First, good thermodynamic is not enough. We have also make sure it's non-corrosive, stable and safe, and not create big trouble, right? So these are something non-trivial. Sometimes you have a good thermodynamic property and much better, but unfortunately it's not safe and it's corrosive, right? So this is something engineering design issue. So we need to find the right material, right liquid to be useful for this kind of air conditioning system. So that in the past, of course, I mentioned so that many years ago, engineer found this kind of free arm can be useful because thermal property good, but unfortunately, this is not good for this our global environment, right? Global warming, and that's why gradually, so engineer find out we need to find better material, right? So that's why there's a series of this kind of chemical, right? CFC, SCFC, and then it's invented for air conditioning system, so that this become important thing. And then of course, as I show you that all of you understand, so that well, this kind of we use a lot this kind of CFC and SCFC, and in general, it can produce some big problem, global warming and ozone depletion. So that that's why gradually all these chemicals have been banned. Why? By the end of 1995, CFC was banned and HCFC was phased out. So this is gradually we need to find a better this kind of refrigerant. So we replace this kind of the old one, minimize the kind of impact, right? And here I show you one of important was a mechanism why this particular chemical is not good for our this kind of global this kind of environment. So that I think this is better to let you look at that one video, right? And then it's much easier for all of you to understand how this can work, right? So that because in general, one of the big problem is so that so here I think this video I would say would be much better for all of you to see how how this kind of how this chemical can really create some big trouble for the Earth. Let me quickly show you here.
Welcome to a brief introduction to the effect of chlorofluorocarbons on the ozone layer. This is a topic that's commonly taught in general chemistry courses, and I thought it would be fun to take a look at it and see if we could animate the mechanism by which the chlorofluorocarbons that get into the upper atmosphere do so much damage. But before we do that, let's take a look at what it's protecting us from. Now, the sun emits a lot of different wavelengths of light, but one of those is what we call the UVC radiation. And UVC radiation is very high energy ultraviolet light, which would be very damaging if it were to reach the Earth's surface and come into contact with us. It would damage our DNA, give us sunburns, and make things generally pretty unpleasant on the surface of the Earth. But we're protected by a layer of ozone which accumulates in the upper atmosphere of the Earth and absorbs that UVC radiation before it can get to us. And chlorofluorocarbons throw a monkey wrench into that whole system. So let's take a look at how. Again, we have UVC radiation bombarding the planet constantly. But as long as there's ozone there, we're safe. Of course, if the ozone were to somehow become depleted and a hole were to form, then we would have a lot of high-energy UVC light reaching the Earth's surface. And again, that would be bad news for humanity. Now, what you need to understand about the ozone layer is that it's not just ozone. In the upper atmosphere, some pretty funky forms of oxygen can exist, not just the O3 ozone molecule, but also atomic oxygen and the usual diatomic oxygen that we're used to seeing at the surface of the Earth. And all of these species are in equilibrium with one another, meaning they interconvert between being an O3 and an O and being two O2s. So what's really going on here is this constant interconversion back and forth. But it always leaves a little bit of ozone there. You notice that in this equilibrium there's always some O3. And that's good news for us because we need that O3 there. Now, the problem that comes with the use of chlorofluorocarbons is that as they reach the upper atmosphere, they change that equilibrium in a way that doesn't suit us very well. So, the normal healthy equilibrium involves atomic oxygen and ozone in equilibrium with diatomic oxygen in a reaction with this kind of stoichiometry. O plus O3 goes to 2O2 and back again. But what happens in the upper atmosphere? When we allow something like, in this case, Freon 12 here, to reach this ozone hole, which I've shown here in this NASA photograph, showing it over the South Pole. Well, what happens when chlorofluorocarbons get up there is they act as a source of chlorine atoms. And that's what gets the reaction messed up. It's the presence of that chlorine atom which catalyzes the breakdown of ozone into O2. So this equilibrium gets thrown out of balance because the chlorine atoms accelerate the decomposition relative to the reformation of ozone. And that's going to mean that the ozone concentration, where there are chlorine atoms, is going to go down. So let's take a look at exactly how this happens from a chemical reaction standpoint. So here's my Freon 12 molecule on its way into the upper atmosphere, where there's a lot of high energy light reaching that area. And in comes a photon of sufficient energy to break that carbon-chlorine bond, creating the chlorine atom, which causes so much damage. Now, a lone chlorine atom has 7 valence electrons, so it's not very happy. It wants to bond to something. And if you work out your Lewis dot formula for ozone, you'll notice that ozone is not a terribly happy molecule either. And so atomic chlorine and ozone can react to form chlorine monoxide and diatomic oxygen. Now, that would be bad enough if one chlorine atom could decompose one molecule of ozone. But what happens next is what's really disappointing. That atomic oxygen that's up there as well can then react with the chlorine monoxide, forming another molecule of O2, but more importantly, regenerating the chlorine atom, which can then go along its way and react yet again. So you'll notice that in my two-step reaction that I've drawn here on the bottom left, that chlorine goes in as a reactant but also comes out as a product. And this is our definition of a catalyst. So the chlorine catalyzes the decomposition of ozone into O2. And one chlorine atom can do this to tens or hundreds of thousands of molecules of ozone. And that is the real danger with using CFCs, that just a small amount can provide the catalyst needed to decimate the ozone layer. That's the bad news, folks. The good news is that ozone production, remember, is in equilibrium. So as we finally start to purge some of those chlorine atoms out of the upper atmosphere, the ozone layer should naturally reestablish itself in the appropriate equilibrium. So there's hope for us yet. That's all for now, everybody. I'm Professor Davis from chemsurvival.com.
Okay, so here I believe this video is much better than you see. Show this kind of animation, how this kind of this kind of freon can really produce some bad problem for the Earth, right? Doing that. So this is something I do think is a much better way to explain about how this works with this kind of animation. And so of course, but of course, again, this has become a very big trouble. That's why there's internationally there are so many countries really want to reduce this kind of CO2 emission, and also ban this kind of CFC or this kind of thing to really save the Earth. So this has become one of most important issue globally, including Hong Kong. Hong Kong government also have to continue to reduce CO2 emission, and also what? So that's why the government provide the funding for green tech, right? This thing for the building engineering. So this is something is a very serious issue, right? So that you can see, because this kind of problem, so that a lot this kind of ice, right, melt, right? So that's something you can see. This has become very, very serious issue, right? And if you cannot continue to reduce this kind of CO2 emission, and cannot try to get rid of this kind of problem, and then we do have big trouble. This is very bad. Yeah. So one student asked, what if we can find a new kind of chemical catalyst for conversion oxygen to ozone? And can we really minimize the kind of problem of global warming? I think it should be possible, but it's possible. Okay, I think that is a good question. It's possible to come up with a new technology to to solve the problem, right? To solve the problem. I think the problem is possible. I do think this, but it is really take time. Why? If you can find some new kind of catalyst can really save the world, and then maybe you get Nobel Prize. So that what student asking, so that if you can really find with some new kind of solution, you can get the Nobel Prize. That's something a big trouble globally. Not only Hong Kong, many countries have to work together. So this is it's non-trivial. It's non-trivial problem. Okay. And of course, let me see. Oh, this is another quite important thing. Why, as mentioned, our traditional air conditioning system, I hope still remember now. What do we have? Typical, if you look at the first video we showed in this lecture, we have what? We have this kind of evaporator condenser, right? And then we have a expansion valve, and also that compressor. So that and then what's the problem? The typical air conditioner we show in first slide is a compressor can produce a noise, right? So that in this case, people want to find, hey, can we come with a much quiet air conditioning system without compressor? So this is an important question I say all you, why? So that can we find a new 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 design without this kind of a compressor, right? Very noisy compressor. So that so this particular one is the one without compressor, doing that. So that without compressor, then use this kind of absorption mechanism to replace this noisy compressor. So that this is something quite important for all of you to think about. And actually, this idea is not new. It was invented by Michael Faraday. All of you probably learned this kind of physics. Faraday had Faraday law, right? Faraday's law, so that and then so that well, once you say why compressor is so noisy, it's some mechanical, just like engine in a car. When you turn on engine, you have high speed kind of motion, right? Piston cylinder, and then so that I don't know if you have ever look at those typical engine in every car, huh? And compressor is similar. You have a piston cylinder, so that you once you have high speed, this kind of this kind of motion, right? And then you can create some very noisy thing. By doing that, this is something I don't know if you have ever looked at engine in in our bus or car. So typically, right, compressor is similar to kind of thing, so that you can create this kind of very noisy, this kind of thing. Why? So that I do think you don't like very noisy air conditioning system, right? So that the engine, compressor, all this is similar as the piston cylinder. Do that. So this is something create very noisy. So I don't know if all of you have ever seen this kind of compressor in work, how they work. At least you look at it's some kind of rotating machinery, right? So that this can create this kind of thing. Once if mechanical this system, then maybe you can look at the similar to the engine. Okay, anyways, it's a good question from the student. Let's just look at here, compressor.
This air compressor consists of an electric motor that compresses air into a storage tank. The compressed air can be released at chosen pressure when required. How works an air compressor? What are the criteria for selecting a proper air compressor?
No, I just showed
Continue with an overview.
Yeah, it's a piston cylinder.
Normally, the compressors used in the field of automation and workshops are the so-called positive displacement compressors.
Similar to the engine.
Here, pressure is excited.
You have this kind of piston cylinder. Once you high speed, this kind of thing, and then if you have certain kind of imbalance of this kind of piston cylinder in a compressor, similar engine, you'll be very noisy. That's why typically for old car, do you see? For very old car, things it's much more noisy sound, right? If a new car, then piston cylinder, and then you most likely produce some good balancing, then you have less vibration and noise. So this is some typical mechanical thing. Why doing that? All this engine and piston, basically you have some kind of rotating, right? Piston cylinder, and then so that go back and forth, right? Doing that, so that you have piston and cylinder, right? So that the rotating machinery, and then so that and then in this case, you most likely once high speed, then you generate kind of very noisy, why? If you don't do the proper this kind of maintenance and do the balancing of piston cylinder. So this is a typical thing, right? Actually, piston and piston cylinder in do that. So this is one of the basic component, right? In all this kind of engine and compressor, so that I just want to let all of you understand, so that this is one of a big issue for all the traditional air conditioning system, right? So that this absorption cooling basically is replacing compressor by this absorption, this kind of a device, and then so sometimes you additional solar panel to think. Okay, so that this is something. And of course, now we should switch to another topic. In Hong Kong, especially in Southeast Asia, we're hot and humid. So that, as I mentioned about our previous lecture, why human thermal comfort relate to temperature, humidity, airflow, and other things. So the humidity is a big issue. Why? For human thermal comfort. That's why we give you this kind of PMV, the human thermal comfort index. So that in this case, typically, this kind of humid air is first, it's not healthy. It can create some kind of a mold, right? And all this is not good, right? Mold and the only thing is not good. And then of course, this also once a very humid, and then create a lot more some other problem. Okay, cockroach, flea, and medicine. So it's something is a health issue in a building, right? In our apartment and homes, right? This is, and then of course, typically, how can we minimize? You can see this kind of how can we reduce this kind of moisture over humidity, so that and first, okay, we need to think about how we can how this works, right? Basically, a certain kind of condensation, most likely, right? If the humidity in the air is too much, so those water vapor in air may easily try to have phase change, right, on the surface of our wall or sitting and the floor, right? So then it could be trouble, especially in spring, like in Hong Kong. You can see in recent like 1 to 2 months, we have this kind of spatial season, and you see sometimes our floor is all wet, right? So that is a very big problem, right? So that and then of course, once you have humidity too high, and then create this kind of a big problem, health problem, right? And also degradation of this kind of building material, right? We have this kind of peeling and exterior wood plan, right? So this is some really big issue for especially the building in Hong Kong, I would say. Of course, another issue is Hong Kong actually surrounded by seawater ocean, so that once you have not only the humidity, right, very humid air, and then with additional maybe some salt from ocean, so that can be also another issue for corrosion. So that actually doing that, this kind of high humidity is first create some problem, right? Have some mold, right? Mildew growth, and of course, for Hong Kong building, we have another problem, huh? So those kind of the salt from where many this kind of salt from the ocean, right? Maybe also try to evaporate now in the air, right? So that in this case, sometimes this one can create some problem, like corrosion problem, right? Doing that. So these are something, unfortunately, in Hong Kong, we need to deal with this issue. So that's why typically, how can we control humidity? I think all you may use, right, those kind of go to this kind of parking shop or Fusion to buy a little small bag of this kind of dehumidifier. Right, that's something is okay for small this kind of area you can do, but for a building, in this case, you have some additional machine, right, to do the kind of a dehumidifier, right? So that's something is important. Typically, so that of course there are different way, right, to reduce humidity or for the building, and one is maybe through insulation of stone window and insulation window, right? And then in this case, you can think about in this case increase the temperature of this kind of the wall surface, so that in this case you can minimize this kind of condensation. Remember, so this basically why we have this kind of wet surface on the floor or the wall, because of condensation. So that if you are able to have additional this kind of material, then it can minimize this kind of problem. So this is one solution. The second solution is we may want to use those kind of dehumidifier, like desiccant, right? So that's something you go to the parking shop and Fusion, small bag. That's something for it's okay for small area. But if you want to not one room or one building, then this kind of thing may not be good enough. You need additional what? Forced convection, right? So that in this case, typically you have this kind of that's actually one is compressor-based dehumidifier, another desiccant dehumidifier. These are two major of this kind of machine, right, to be used in the building application, right? So that so first is this kind of compressor type of dehumidifier, right? So that basically you need to think about is go through the kind of thermodynamic process, how we can use the kind of compressor and then with a cooling coil, and then let those kind of humid, this kind of air, right, go through condensation and then reduce, turn this kind of water vapor in the air into this kind of a liquid water, right, collected thing. So this is as one of very common way to do dehumidifier. So that, do you understand? So I think majority of you probably have seen this kind of compressor type of dehumidifier. Okay, so that it's a low cost and can be useful. But of course, what's the issue? Do you have any idea? What's the problem of this kind of compressor type? The same thing, typical, similar to the traditional air conditioning system we mentioned in the first video, right? We can also quite noisy, right? So that I told you, do that. Once a compressor, then just like engine is noisy. So that there's another one is desiccant type. So that if you add this kind of thing, look here, this kind of thing, then there's another family, desiccant type of this kind of dehumidifier. In this case, we don't have compressor, right? So that is something. Maybe you can quickly look at that video again, so that then it's easier to see. Right? I do see the video is much easier for you to understand the process. Yeah.
And welcome to Smart.
Look at this video and quickly understand this kind of design.
Family of cooling products. Today, we want to introduce you to our RDDH desiccant dehumidifier. We can tell you that this 6,000 CFM dehumidifier, what makes this unit so special? Well, aside from the 400 millimeter wheel, which is twice the thickness of industry standard. In general, a desiccant dehumidifier is simply a modified thermal wheel. Okay, so what does that mean? As we show you here, this wheel is split into 4 quadrants. The way this works is we run 2 opposing air streams across the wheel while it rotates at a very slow speed. We run process air across 3 of the 4 quadrants. And in the last quadrant, we run heated air in the opposite direction. We call this reactivation air. Now, as this wheel rotates, moisture is being removed from the process air, which drops the grains of moisture per pound and in turn reduces the relative humidity. So when the process air leaves the wheel, it is now much drier than when it entered. But what happens to the moisture? Well, that's where the reactivation air comes into play. This air is being blown by a completely separate blower and a completely separate airstream. And this air is passed across electric heating elements prior to entering the wheel. So, we are raising the temperature of the air drastically. Now what happens is that all the moisture that was collected from the process air is now drawn out of the wheel as it passes through the hot reactivation section of the wheel. So what you now have is roughly 1,500 CFM of hot, very humid air coming out of the react side of the wheel. This air then gets ducted away from your process location, typically outside. Now, this has been a very basic overview of how a desiccant dehumidifier works.
Okay, so this video, I still think it's a little bit better than these pictures, right? Is that once you see this one, then it's much easier for you to understand how this works. Okay, and again, so that that's okay. So I think of course, when we look at this kind of family of design, and then we may need to consider about what kind of this kind of material used to as a desiccant, right? So this anyway, so in this case, I told you there's a when we look at this particular design of this kind of dehumidifier, so definitely we also need to understand what kind of material used, right, for this desiccant, right? So that here I just show you there's a possible way this kind of material using in these drying agent, right? So typically there's a long list of different chemical can be used, right? So that okay, and anyway, so that this video already show you this kind of how this kind of dry desiccant wheel work. I said I can skip this part, and then so that again, so that compared with compressor type the design. So this case in first is you don't have this kind of much smaller noise for sure. There's no doubt at all, right? And then in this case, the way to work is a little bit simpler, right? So that's something we just show here, and okay, so that of course I show you there's a different type of this kind of desiccant used in dehumidifier. One previous one show you if solid type of this material. Of course, there's another one is maybe some people may use like a liquid desiccant to absorb those kind of moisture, right, in the air. So this is also possible, right? And so then, of course, you can see that there's at least for this kind of liquid type of design, then most likely it will be a little bit more complicated because you need to think about how to manipulate this kind of liquid desiccant and then go through the kind of process to remove those kind of moisture in the air and turn into this kind of liquid water. Okay, and in general, I think we almost run off to the end of this lecture. So for air conditioning system, so that again we have shown you a series of different design of air conditioning system, right? From very basic one, right? 4 key component: compressor, evaporator, right? Basically, we for one of the most important thing, I think hopefully you understand now, why we have some heat exchanger, condenser, evaporator, and then we have a compressor and the valve, right? So these 4 key components, and gradually we also introduce a series of new design of this kind of air conditioning system, so that as show you that there's no perfect design. Depends on how first it's cost and that's performance, right? So that that's the thing, right? So that of course we also mentioned about that additional seawater based this kind of air conditioning system, which can be useful, especially like for Hong Kong, this kind of thing next to this kind of ocean, right? So that in general, when we look at this thing, and then again, we for all this engineering design, we need to think about now in terms of cost, right? And what kind of design of this air conditioning system we should use, and also the benefit and other things. Right? There's a series of engineering issues for this kind of practical application of air conditioning system, right? For different building maybe they have different kind of requirement, right? So to choose right this kind of air conditioning system, okay, and of course finally I show you that again the one of the most important issue now for air conditioning system is how we can have more this kind of better environmentally friendly design to reduce this kind of global warming effect. So that I just show you this is we have a series of this kind of chemical using as a working fluid or refrigerant, right? So that is something quite important. Okay, I think we finished this this chapter. Do you have any question? Any question for this lecture? If not, I think we need to go to the next one. Okay, so the next one will be this water supply. Water supply is another very important issue, especially in Hong Kong. Or even in mainland China, so that in general we don't have enough water, fresh water. So that how can we be practical, right, to make sure we can really efficiently use those kind of water, right, for the building and for the city. So that in general, I think we can quickly show you the important issue, right? So that we talk about this kind of water resource in the world and the water quality and other things, right? In Hong Kong, and then what's the typical way Hong Kong can provide this kind of fresh water supply. Of course, Hong Kong also, in order to minimize consumption of fresh water, government also use seawater, right, for flushing of the toilet. So this is unique for Hong Kong, this kind of water supply. So that in general, we have a lot of water in the earth, and do you think a lot of water, but unfortunately, not all the water can be useful for us. Do you think that is a big problem, right? So that in the earth we have large, big amount of this kind of water, most likely in ocean, right? But the seawater, and then you cannot drink the seawater directly. And then so that and then with this proper heat transfer, right, in the earth, so that we can have this kind of water cycle, right? Evaporation, and then it can rain drop and run off. Right? So this is typical thing happen almost every day. And then the key thing here is this kind of water cycle. Again, it goes to what? Heat transfer. We have this kind of heat transfer not only inside the building, but also in the earth. We have from ocean or lake, we have some evaporation, phase change, right, from liquid to vapor, right, evaporation, and then condensation, right, become the cloud, and then precipitation. Then you if you have too much this kind of cloud and precipitation, and then have raindrop, and then in this case we have some kind of heat convection of this kind of water go through this kind of and then become going to this kind of lake or ocean. So this kind of water cycle is become, I think, quite important thing, right? Of course, beyond this kind of typical this kind of water cycle, we also have other problems. Not only the typical rain, snow, and what else? Hail. So this is another big problem. So here I show you. So what is this kind of what's the problem of this kind of thing? Any idea? Basically, hail formation, it turns out, is an important and big problem. So that I show you this how hail work. I think there's one video. Sorry, sometime, but I do think we have this video on our Canvas website. Let me show you this. You can look at the video. We have video clip. Let me show you hail. Oh, here. You can look at the, let me show you this. Here.
Have several potential hazards, including wind, lightning, heavy rain, tornadoes, and hail. Hail is formed through two processes which create layers within the hailstone. Strong updrafts, which are rising streams of air, in some thunderstorms pushes rain and ice pellets high into a thunderstorm, keeping them suspended within the storm. In this area, both ice pellets and water droplets are found. Temperatures in this area are below freezing, but due to atmospheric conditions, water droplets can remain in liquid form. However, once an ice pellet comes into contact with a water droplet, the water begins to freeze. If the water freezes slowly, it creates a layer of clear ice. If freezing occurs quickly, the ice is cloudy due to a lot of air bubbles being trapped in the ice. If you examine a hailstone, you may be able to see layers of clear and cloudy ice. The hailstone may fall out of the updraft, but then get pulled back in and carried up again. This may happen several times, making the hailstone grow larger each time. The longer a strong updraft is present, the bigger the hailstone may become. Eventually, the hailstone becomes too large to suspend in the air, or the updraft weakens, allowing the hailstones to fall to earth. Small hail does not take strong updrafts to be formed. For example, pea-sized hail can form with updrafts of only 24 miles per hour. Very large hailstones require much stronger winds. Softball-size hail would need an updraft of 103 miles per hour.
Okay, so this video can give you some simple explanation why we can have this kind of additional, I would say it's also phase change. Why? In terms of heat transfer, that means we have some water vapor in the air due to this kind of unique, this kind of convection, and then so that the water vapor turn into this kind of hail and then become bigger and bigger, right? Until reach some critical size and fall down. So this can be dangerous. Do that. They can create some big problem, damage the building, damage the car, and maybe hit the human and then cause some injury. So this can be very bad. So that in general, here if you look at, it turns out it do have some create some big problem. Typically say hailstorm can damage can create this kind of loss of $1 billion US per year. It's a very big money due to this kind of spatial phenomena. So severe hail, it typically is bigger than 1 inch diameter or 2.5 centimeter. Okay, and if you're very large, this kind of hailstone, and then in this case, you can have really big trouble, can damage a lot this kind of building and also even a car and other things. So it's I think it's a very big issue. Why? So that again, so you can see it's happened very common. I mean, 45,000 of thunderstorm and take place every day, and then in between there's a certain kind of 2,000 to 3,000 some special type of supercell thunderstorm this has chance to promote this kind of spatial convection, and this can be important to trigger hail formation. So this is something unfortunately it can really can be bad in some things. Of course, you may also look at that kind of what we call the supercell thunderstorm. Okay, and so that here this is the typical way to show about what's a typical hail activity in the United States. It depends on the region. some region has a much more this kind of problem. Okay, of course, if you look at in China, actually still it also happened in some area, but not everywhere. Some selected area have happened much more this kind of hail activity. Okay, and okay, so here let me talk about another issue, right? So that in general, water is important for everybody, right? Not human, but all the animal and plant. So that in this case, when we look at this kind of water, and then a key thing here is human or use, while we have to drink water every day, right? And then so the key thing here is how can we produce this kind enough fresh water, right? So this is in general it's a big issue, right? Another thing is water hygiene, right? Hygiene basically is if you have this kind of water, once is we can for drinking water, and another thing how use water to cleaning, washing, right? So this is something quite important. Of course, for COVID-19, now we have two important ways, right? Wear the face mask and wash your hand, right? So you can really minimize the spread of this kind of virus or bacteria. So this is something important for everybody, right? And of course, one of the big problem of water is we have a lot more water, and but many water is useless. Why? So that how much water we can really use, right? It's a practical application of water. So that typically that's something you see. If you look at the Antarctica of the Earth, so that they have 70% of fresh water on the planet. Okay, and that of course that is ice, right? So that in this case we need to think about how this kind of water can be useful, right? From the Earth and for us to use, right? Typically, of course, this kind of when we look at this kind of water cycle, and then so one important thing is we need to think about those solar radiation issue, right? And then so that that's related to this kind of albedo, this kind of effect, so that solar radiation will create this kind of energy transfer, right? And so that different surface, if you ice or this kind of ground, right, the soil or ocean, so different kind of this kind of albedo, and then different kind of heat radiation issue, right? So that in this case, in general, for the Earth, we have most of water is useless. In the ocean, you see 97% is saline, right? The ocean, and only 3% fresh water. Among 3%, and then we have a large percentage of this fresh water we cannot really use. Ice cap or glacier, right? So that only 30% is in groundwater, and about 0.9% surface water. It's quite important for you to look at this kind of ratio, right? 0.9% or this kind of thing, then we divide into some area. No, the water, fresh water is a lake, and some swamp and river. So this gives you a good understanding. Only very small percentage of those water we can use, right? A lot of water is useless. So what do you think? How can we solve problem? In Hong Kong, we had to buy water. Can we have some better way? It's a quite important thing as engineer, right? What do you think? So it's Hong Kong surrounded by ocean, but we cannot already use this kind of water from the ocean. How can we do? Any idea? It's an important. Can we review? Can we use ocean, water for Hong Kong? Oh, well, one student mentioned about this kind of process, desalination. One student mentioned, very good. So that in some country, they really spend a lot of money to produce this kind of special plants. For example, Singapore, I know that they really have this kind of a shortage of water, fresh water. They even buy the water, fresh water from Malaysia, or they have their own this kind of Singapore to have this thing, and Saudi Arabia. They have a lot of oil, but there's no enough fresh water. So they also put a lot of money to build this kind of special plant for desalination. So this is in Hong Kong, we buy a lot of water, from Guangdong province. So can we try to have this kind of no? At least I know Singapore government actually put a lot of money have this kind of desalination. It's not small. Singapore government really put a lot of money. It's not small money, because this is a critical issue. If those Malaysia, they don't sell water, then they will die. What do you say? So that I tell you, some country they treat this one as very serious issue. So that Singapore actually they really put a lot of money to produce this kind of special plant, produce fresh water from ocean, right? So that like Saudi Arabia also put a lot of money. In the Middle East, they have a lot of oil, but they don't enough this kind of fresh water, right? So in Hong Kong, it's something we buy a lot of water from Guangdong province, yeah. And again, so that so when we look at this kind of water supply, one important issue is the pollution problem. So that how we can really minimize the kind of pollution, so that make sure that we can really have a much large percentage of water can be useful, right? So this is important. I think we already mentioned about this stormwater runoff issue in previous lecture, right? I hope I will not talk about too much. Hope you still remember our previous one chapter had mentioned about stormwater runoff, right? And then so that and of course the key issue is we need to think about this thing, how this kind of we can really minimize this kind of problem, stormwater, and create this kind of trouble. So this is an important issue, right? So that if we don't solve the problem and then create some big pollution issue, so this is something I think all of you have seen this kind of sedimentation. While once we have a big rain, and then so those kind of big rain will cause this kind of stormwater run off, and then cause some pollution, right? And this is something not good, and then create some pollution problem. So that you can see this is a typical issue for this kind of pollution, right? And so that a key issue is how can we solve the problem, right? Okay, another important thing is I think all of you know that we have another possible way to get fresh water from underground water. So that this is another important thing. Of course, unfortunately, what's the problem of this kind of water from underground? What's the problem? Especially, I think, mainland China, we have many manufacturing plant illegally to doing manufacturing process have generated a lot of pollution, water pollution. So that in this case, if you have a lot of pollution, and then from the many manufacturing plant, it can cause some pollution of this groundwater. So that in this case, I would say large number of this percentage of this kind of groundwater may be in mainland China may be not useful. So this is another big issue. Okay. Okay, so here we have another branch of this issue now. So what's this? Eutrophication is another issue about pollution, water pollution problem. So that so basically, I think I also have a video. Let me show you. We have again this can be, you can see this kind of video from our Canvas website again. From our website, I remember we do have that video. You can, yeah, here, let me show you this video. It's much easier.
Plants require several things to grow. Most of us know that they need things like water, sunlight, and CO2, but plants also need a variety of nutrients as well, things like nitrogen and phosphorus. Usually, plants will get all their required nutrients from the soil through their roots, but when the soil is bad or there's been a lot of erosion or leaching, farmers or even just people trying to make their lawns green will put down something called fertilizer. What makes fertilizer so fertile is that it's been enriched with these nutrients that the plants need, again mostly fixed nitrogen and phosphorus. But plants aren't the best at soaking up every last nutrient in the soil, and it's also hard to gauge just how much fertilizer a field needs, as soil quality can vary drastically over short distances. To be safe, farmers will usually apply excess fertilizer to a given plot of land. Better safe than sorry, you know? But instead of staying in the soil for years, most of the excess nutrients will be carried away by the rain or other forms of irrigation. These nutrients mix with the water and find their way into bodies of water like ponds, lakes, reservoirs, and even the ocean sometimes. With all these nutrients added, the algae, phytoplankton, and even plants in the water do the same thing the crops in the field do. They grow. Well, actually, they explode in numbers. This is called an algal bloom, and entire lakes can become covered in layers of plant growth like this. To some, this might seem like a good thing. Plants are good for the environment, right? Well, not always. First off, this floating layer of algae forms basically an impenetrable roof on the water, not allowing sunlight through to the bottom of the lake. Without the presence of sunlight, all plants below the surface cannot partake in photosynthesis. You know, metabolize, make glucose, live, that sort of stuff. But not even this is the bad part of it all. Many plants can store enough energy in their bodies to wait out these conditions. The real problem comes when all the nutrients are used up and the water can no longer support so much life. When this happens, the excess algae, phytoplankton, and plants die off and sink to the bottom of the body of water. Here, bacteria and other decomposers feast on the dead bodies in a chemical process of decay which consumes oxygen. Now, in a usual ecosystem, the amount of dead matter is relatively constant, so oxygen levels stay relatively constant as well. But when a bloom occurs, far more organic matter is ready to decompose, and so nearly all the oxygen in the water is used in the process of decomposition, and none is left for the animals living in the water. Without this, animals that use the dissolved oxygen to breathe, so things like fish, can actually suffocate. This causes even more death, leading to more decomposition and more oxygen usage. Basically, at this point, a positive feedback loop has been created. It can take a body of water a very long time to recover, though each one is different, and recovery depends on a lot of things, like how many nutrients leaked into the water, how big the body of water is, what organisms are present there, and so on. When this happens in lakes, native species can be suppressed and allow invasives to come in while the environment is still disturbed. If this happens in the ocean, the lack of oxygen can cause corals to bleach and possibly even die. All around, this can greatly damage many ecosystems and leads to a decrease in biodiversity globally. Nutrient-rich runoff can also be caused by things like clear cutting, which releases the nutrients which were kept in the soil by the plants, or also by things like animal farms, where nutrient-rich waste materials can leak into local bodies of water. And that's eutrophication, simply put. I hope you enjoyed the video and maybe think twice before using fertilizer or clearing a forest. If you want more people to see this video, give it a like, and if you...
Okay, so I do believe this video can quickly let you to understand this kind of process, right? So that again, the key thing, again, pollution. So we have a pollution, and then human use a lot of kind of fertilizer, right? And then so they create this nutrient for those kind of microorganisms, especially like plankton, right, in the ocean or lake. So that in this case, you can really create the big trouble, right? Then so those kind of things really create some big trouble for this. And this is quite important for all of you understand about pollution of this kind of water, right? Can create a big trouble, right? So that this is something. It's not only the lake, seawater, ocean. We also have this kind of issue. Like in Hong Kong, I don't know if you have you seen this kind of a problem for our ocean? Huh? Ever see this kind of problem in Hong Kong? Huh? No, you never see this kind of they call the algal bloom. Did you see this kind of a problem in Hong Kong? I do think Hong Kong government do try to monitor about this kind of algal bloom, so that is actually locally is an important issue. Let me quickly show you this thing. In Hong Kong, we do have algal bloom, so that I believe maybe some of you have seen this kind of happen. So that again, once was the pollution, and then we let this kind of many kind of spatial plankton in the ocean to quickly grow, right? And then so this creates some big trouble. And what happened? Once you have this kind of thing, and what happened? Many fish die, right? So that this creates some big trouble. So that actually I do have this kind of project, ongoing project with our former Vice President of our UST, Professor Lee, so that work with this kind of our Hong Kong government, FCD, right, to solve this problem with this kind of actually my PG research group work with this kind of AFCD and make this kind of low cost smartphone microscope with AI, and then how we can try to really quickly identify those kind of small, very small, this kind of algae or this kinds of microorganism, we can create a big trouble for Hong Kong seawater. So this is something is a real problem for Hong Kong, and I do have ongoing project with the Hong Kong government, and also the funded by ITF, so that maybe if interesting, I do think I do have that Europe project. You may want to see if they want to join this kind of Europe project. Okay, so that do you understand? I tell you that we are almost the end of semester, so that if you want to looking for summer the kind of internship or even summer project, so that at least we have a series of this kind of project you may want to consider. Okay, so this is one again, it's a important problem in Hong Kong, and then so that I got this kind of joint project with the Hong Kong government, and also joint project with Professor Lee, the thing. So that if you're interested, you're welcome to look at this kind of project, okay, on Europe website. Okay, so I don't know, do you have any question for this problem? Is still important issue. That's why we got this kind of special funding, why, from Hong Kong government to think about how you use this kind of a smartphone, local smartphone microscopy, and then take the picture about all this kind of small microorganisms, right? Algae, and then among this kind of many types of this algae, so that it's about 20 of this kind of species they can really create problem. Why? For this kind of algal bloom. Why? So this is something I should tell you, it happened. I have this some project, so that let me put down. There are many different type of this kind of species. Right? About 20 type of this ones will be bad produce this kind of algal bloom. So this is I haven't so that this I do have this kind of ongoing project with the Hong Kong government and also with Professor Joseph Lee. Okay, so let's give you this additional information. Do you have any question for this thing? I think it's still an important issue for Hong Kong. And again, once you have this kind of thing, big problem is many fish die. Many of you in Hong Kong people like seafood. If we have this kind of big problem, and then algal bloom, and then many the seafood will cause some big trouble. So that this is an important issue. Why? So that's why. Anyway, so that we have tried to look at another thing. Anyway, so that in general, for this kind of water is again is a very important for everybody, for the world. Why? So that but unfortunately we have a population in the earth continue to increase. Why? And then pollution, we have a lot more pollution, and then in this case our real fresh water is not enough. So this I would say in the following many coming 1 or 2 years, it seems it's a big problem. I don't know if you have seen some of prediction, right? So that it is in China, so that in the coming 1 or 2 years, we have suffered shortage of water supply. So it's a big problem. Sometimes we have big, this kind of typhoon or flooding, right? But on the other hand, we have a shortage of this kind of fresh water. So this is another global climate change. So we have a lot more this kind of violent, this kind of thermal cycling. So that suddenly we have a lot more water. And then, but on the other hand, we don't have enough water. That means we have in general we have what's that? Let me show you this kind of interesting. So that now we have this kind of thermal cycling. We have a high temperature, low temperature, and then thermal cycling, so that produce much more typhoon, much more storm, right? And then so that suddenly too much water, suddenly have no water. So it's extreme this kind of thermal cycling, and this is something in the following 1 or 2 years, I would say this can be a big problem. I think, yeah. Anyway, so that I don't know. Do you have any question or comment? Again, so that water pollution is a important issue. Okay, so that one is human-made. Why? As I show you in the video, so that we try to use many fertilizer. We also use many detergent. Every of you, every home, we have this kind of use detergent to clean up our this kind of container, right? And wash clothes, and then all this kind of fertilizer and detergent, soap, and produce this kind of pollution, right? So that this can be. Another hand, we also measure this kind of air pollution, right? Water pollution, okay. And so again, we have a series of the different possible pollution for the water: household, industrial one, commercial, farming, and construction. These are something not good. And of course, in this case, once you have this kind of pollution, and then we will produce some issue about water quality, right? So that of course, in those kind of water engineering, so that they define what kind of quality, right? From drinkable water, right? A safe one, and then to very bad. Why? Skin touchable, eye touchable. So this give you some idea about this thing. Okay, so that so this is give you another way to see about different quality of water. And of course, in general, when we look at this water quality, so that we need to think about how can we have more quantitative way look at this kind of water quality. Why? Typically, water quality, we can look at those kind of chemical. Why? Those concentration of chemical in the water. Physically, if a very dirty water, biologically, maybe we have a lot of kind of microorganism. Why? So that in this case, we need to think about all these kind of issue. Why? And also some water have bacteria or virus, COVID-19 virus. Hong Kong government every day they look at those wastewater to see if the COVID-19 virus or bacteria. So this is something I think it's an important issue, right? And then of course, in terms of some water, we look at the turbidity, right? If you have very dirty water, right? And then we have this kind of alkalinity, right? If a lot of kind of a special salt in the water, and this is something not good, right? So that and of course there's a series of way we look at those chemical, right, in the water, right? So that the CO2 and some trace elements, some iron, copper, or this thing is some important thing, right? So in general, we look at the color of the water as at least simple evidence to see if you have got some pollution. Do you understand? So different color of water may imply some different type of some pollution. So do you understand? So this is something give you some simple way. Of course, in terms of water engineering, maybe have used a series of much more sophisticated this kind of sensor or some equipment to do the kind of measurement of water quality. Okay, I think we almost run out of time, so that today we quickly finish this kind of air conditions lecture, and then briefly introduce the kind of water supply. So I don't know, do you have any question? Oh, by the way, the TA already prepared this kind of quiz, number 2 quiz. They will be announced probably 14th of May. I think it's good for all of you to start to study some of our lecture material, and then quiz. Second quiz will be released on I think next week. So do you have any question about our course content? And this, I would say, this can give you some exercise, why you need to study about those kind of content. And then, so again, I will officially announce on one student asks what kind of topic will be covered in the final exam. We will try to cover all the material we introduce during our online lectures. If some, of course, unfortunately, we probably cannot cover every topic now, but at least we will those questions in the final exam will be covered now in our during the online lectures. Do you understand? So for those topics, if we don't discuss in our online lecture, will not give you this kind of exam question in the final exam. Okay. Okay. If you have additional question, you can ask question on our